2.1, there's also a section where you have to learn how to simplify a trig identity. An identity is basically just a true statement, kind of like a postulate or a theorem. In geometry, postulates you accept as true, theorems you can prove are true. An identity is just something that's always true. And these are identities that we've already talked about. I just want to kind of reiterate. The Pythagorean identities is sine squared plus cosine squared equals 1. What that means is if you take anywhere on the unit circle, pick a point, and you square the sine, and you square the cosine, you'll always get 1. It's always true. Another thing that's always true is 1 plus tangent squared is always equal to secant squared. 1 plus cotangent squared is always equal to cosecant squared. We know the reciprocal identities, and we know the quotient identities. If you don't have those in your notes, you'll want to put them in your notes because you're going to need them to simplify the trig identities that we are getting ready to talk about. So I'm going to start, and I'm going to do a lot of examples of these so that you have them to come back and look at as you're working through the homework. So I'm just picking things out of the book. The problems on page 223, starting with question number 15, and I'm just going to work through them so that when you do your Delta Math assignment, you have something to fall back on. So I'm going to start with this problem. Simplify will be the directions, and the identity or the expression that we're going to simplify is this: secant of x times cosine of x. So this is just a statement, kind of like if I had a fraction, 2/4, I might say simplify, and in fact you guys could look at this one and already know that it simplifies to 1/2 because you've reduced fractions a lot. It's kind of what we're doing here. We're reducing this or making it in its simplified state. So I'm trying to look for things that might cancel out in order to make this simpler. So one thing I notice here is that secant is the same thing as 1 over cosine. So I'm going to change this part to be 1 over cosine. And that's times the cosine that's already there. Well, I know that any time that I have the same thing in the numerator and the denominator, that is equal to 1. So the cosine in the numerator, the cosine in the denominator cancel, so my answer is 1. So if I take the secant of some angle times the cosine of that same angle, I will always get 1. This is the reduced version of this. Now it's going to take you watching several of these problems to be able to do them on your own. So let's try this one. Tangent x times cosecant x. If you want, you can pause the video, try it yourself, and then come back and watch me solve it. We don't always have to solve these the same. One way I could say is I try to find a way to compare sine and cosecant, but I can't think of any of my identities that have sine and cosecant, or excuse me, tangent and cosecant the same. So what I'm going to do is change this tangent into sine over cosine, and I'm going to change the cosecant into 1 over sine, because that's a reciprocal identity. And now I have a sine in the numerator and a sine in the denominator that cancel. So I have 1 over cosine. And 1 over cosine is the same thing as secant. So my answer would be secant theta.